My dear students, during flame test, beryllium and magnesium salts produce color in the flame or not? This is today's lesson. So, let's go to the detail. The very first point is salts of different metals and colors of the salts in the flame. Let's see. First of all, lithium salts like lithium nitrate, lithium sulfate that produce red color in the flame, where lithium ion is responsible for this color. Then like sodium salts, sodium carbonate, sodium sulfate that produce yellow color in the flame, in which sodium ion is responsible for this color. Then suppose potassium salt, for instance potassium nitrate, potassium sulfate that produce purple color in the flame, where potassium is responsible for this color. Then calcium salts like calcium carbonate, calcium nitrate that produce orange red color, where calcium ion is responsible for this color. But beryllium salts like beryllium chloride, beryllium sulfate that produce no color in the flame. Magnesium salts, for instance magnesium sulfate, magnesium nitrate that produce no color in the flame. In this lesson we are going to learn the reason behind different colors for different salts. Now let's see the steps to perform flame test. Steps to perform flame test. First of all, we have to take platinum wire or nichrome wire. Nichrome wire is alloy of nickel and chromium. Platinum wire, which is inert in property. That is why basically platinum wire is used in flame test. Then cleaning of wire. This platinum wire with wooden handle is dipped in concentrated HCl, hydrochloric acid. Then this platinum wire is placed in flame to clean this platinum wire. Now this platinum wire is dipped again in concentrated HCl, then it is mixed with sample salt. Now this platinum wire with sample salt is placed again in flame, and at that time in the flame we observe a particular color for particular sample. These are the steps to perform flame test. That means we have to take platinum wire, then it is cleaned, dipping concentrated HCl. Now this platinum wire is dipped again in concentrated HCl to convert sample salt to chloride salt, like calcium sulfate reacts with hydrochloric acid, then calcium sulfate converts to calcium chloride. Calcium chloride, that means chloride salts are more volatile. Here, melting point of calcium sulfate is 1460 degrees Celsius, but melting point of calcium chloride is 772 degrees Celsius. That means chloride salts are more volatile. Volatile salts are advantageous in flame test. That is why platinum wire is dipped in HCl, then it is mixed with sample salt to convert the sample salt into chloride salt, because chloride salts are more volatile. Now let's move on to the next point. Now the point is reason behind kala in the flame, and for different metallic salts, different colors. Let's see the matter. When platinum wire with sample salt is placed in flame, then we observe a particular color and different colors for different salts. Let's see the reason. Suppose this is metallic ion, this is nucleus, this is outermost electron. When the salt of this metal is placed in the flame, this ion absorbs energy from the flame, and then this electron jumps to a higher energy level from its ground state, absorbing energy from the flame. But as there is an attraction between electron and the nucleus, it returns back to its ground state again. At that time, it releases energy. So, electrons absorbing energy jumps from its lower energy level to higher energy level, and because of the attraction towards nucleus, this electron from the higher energy level returns back to its original ground level, and at that time it releases energy. This energy is absorbed as kala. So this is the reason of producing kala in the flame during flame test. Now let's see why different metallic salts produce different colors. Different metallic ions with different sizes, smaller size, bigger size, less attraction to the nucleus, smaller size, greater attraction to the nucleus, greater attraction absorbing more amount of energy, lower attraction absorbs less amount of energy, more energy it releases more amount of energy, less energy it releases less amount of energy. As energy is observed as kala, higher amount of energy, a particular kala, less amount of energy, another color. So color of the flame depends on the amounts of energy. High amount of energy, one kind of color, less amount of energy, another kind of color. So this is the reason of producing different colors of different metallic salts. Now let's see what about beryllium and magnesium salts. What will happen when beryllium and magnesium salts are placed in flame during flame test? First of all, let's see the location of beryllium and magnesium in the periodic table. Beryllium and magnesium belongs to column 2. Calcium, strontium, barium and radium. We know from bottom to top atomic sizes decrease like this. So beryllium and magnesium ions are smaller in size. Now let's see what is the factor of smaller size. Beryllium smaller in size, magnesium smaller in size. Smaller size, a high attraction of electron towards the nucleus. Similarly, greater attraction of the electron towards the nucleus. Because of the high attraction, the Bunsen burner cannot provide this sufficient amount of energy so that electron can jump from its ground level. Similarly, for magnesium, because of its smaller size, Bunsen burner cannot provide that amounts of energy by which electron can jump to the higher energy level. Because of its smaller size, beryllium and magnesium ions do not show colors in the flame during flame test. Because Bunsen burner cannot provide sufficient amount of energy to excite outermost shell electrons in case of beryllium and magnesium salts. As the salts are converted to chloride salts, for chloride ion, it absorbs energy and releases energy, but this energy is not in the visible region. That is why chloride ion has no effect in producing color in flame during flame test. So this is all about salts of beryllium and magnesium. That means beryllium and magnesium salts do not produce color in the flame during flame test because of their smaller sizes. Smaller size, Bunsen burner cannot provide sufficient amounts of energy, and electrons do not jump to the higher energy level from the lower energy level. And as a result, the salts of beryllium and magnesium cannot produce any color in the flame during flame test. No more today. Thank you very much.